this video is all about this bad boy, the periodic table of elements. And the periodic table of elements, I know, looks terrifying at first, but the thing about it is, it's just a matter of learning how to read it. So once you know how to read it, there is a ton of information on here, and what's not specifically written on here, you can use this to figure out the answers, basically. So the worst part about this is just figuring it out. So I'm going to teach you how to read it right now. Before we can talk about how to read the periodic table of elements, though, we need to talk about what an element is. And an element is a substance that can't be broken down into simpler substances. The reason that it can't be broken down into simpler substances is because it's made of only one type of atom. So if you break it down any further, you're not going to have atoms anymore. You're going to have protons and neutrons and electrons. So that's what an element is. And if you think about chemistry as being a language of its own, which it kind of is, all of the elements are the alphabet. Each element is a letter. So the periodic table, little history. First, the guy that created it, his name was Dmitri Mendeleev. And he was a Russian scientist who, back in the late 1800s, looked at all of the elements that were known at the time and realized that there was a relationship between the properties of the different elements. So he took all of the elements and he put them into a chart to make it easier to figure out what those properties are. And that was the beginnings of what we know of today as the periodic table of elements. At the time, though, there were only 63 elements, and today there are 118. So you can imagine there were a lot of blanks on there. The cool thing, though, is that he realized that we could figure out what properties those unknown elements, those blanks that were on his original periodic table, what properties those elements should have because of where they are on the periodic table. And the thing is, he was right. That's why we still use his model today, is because the periodic table shows us all those different properties. So how to actually read the periodic table? Like I said, it's got all of the elements on the all the elements that we know of are on there, and they're organized in a specific way by what's known as the atomic number and the atomic mass. And we'll talk more about what those two are in just a few minutes. The other thing that you'll notice when you first look at the periodic table is there are a bunch of letters. The reason there are a bunch of letters is because each element is given a symbol, and it's going to be either 1 or 2 letters long. The reason that, and when you look at it, some of them match up very, very nicely as far as H is hydrogen, O is oxygen, C is carbon. A bunch of them match up very nicely like that, so it's pretty obvious what element goes with what symbol. Not all of them are that easy, though. For instance, iron is actually, the symbol for iron is Fe, because in Latin, iron was called ferrum. So the symbols are based on the names in either English or Latin. So that's why you can't just assume that the first letter of the name is going to be the symbol. When you're writing it, it's very important. The first letter is always, always, always capitalized. The second letter, if there is one, is always going to be lowercase. That way we can distinguish where one element begins or one element ends and the next one begins. And like I said, the periodic table itself, the entire thing, is designed to show patterns of properties of all the elements. So you can look at the periodic table and figure out the basic properties that an element is going to have based on where it is on the periodic table. Before we get into how to do that, though, let's talk about each individual box on the periodic table, because this is going to give you a lot of information. So every single element has its own individual box that looks like this. There's a whole number at the top, 1 or 2 letters, the name, and then a number with a decimal. Each of those tells you information that you need to know about that element. So we're going to talk about what those are. The first one we're going to talk about is the whole number at the top. This is called the atomic number. And this is the box for oxygen, and its atomic number is 8. The atomic number tells you the number of protons in an atom. So oxygen has 8 protons. And that's very important because the number of protons in an atom can't change, or in an element can't change. If you have 8 protons, you have oxygen. If you have a different number of protons, you have a different element. The other thing that the atomic number will tell you is sometimes it will tell you the number of electrons. This is only in neutral atoms though. So if it's not a neutral atom, and we'll talk more about that, what that means later, but if it's a neutral atom, meaning that it doesn't have a charge, then it has to have the same number of protons as it does electrons. So in neutral atoms, the atomic number is also the number of electrons. So oxygen, when it's a neutral atom, has 8 protons and 8 electrons. The second thing is the symbol. And in this case, O is the symbol for oxygen. That's just what represents the element. The third piece of information in the box is the number at the bottom that's a decimal. This is known as the atomic mass. And if you remember back to when we talked about protons, neutrons, and electrons, protons and neutrons each have, when you talk about one individual proton or one individual neutron, it has a mass of 1 atomic mass unit. And so they're about the same size. Electrons, remember, are infinitely smaller, so they don't really factor into the mass of an atom. So the atomic mass is essentially the number of protons and electrons, or number of protons and neutrons. So we can use this to find the number of neutrons, because we know that oxygen has an atomic number of 8. So it has 8 protons. We can use that to figure out how many neutrons it has. The way that we do that is we use this formula right here. Number of neutrons equals the atomic mass minus the atomic number. So in this case, you'd say 16 minus 8 equals 8. So oxygen has 8 protons and 8 neutrons. It doesn't always work out that way though. It can have a different number of neutrons than protons. The other thing, you'll notice that there's a decimal here. In this case, they're both zeros. That makes it easy. But that's not always going to be the case. If there was a decimal here, you would have to round to the nearest whole number, because you can't have a half a neutron in an atom. So if you do have a decimal that doesn't come out to be an even number, round to the nearest whole number. So that's what each box on the periodic table tells you. There's a ton of information in there. Now let's look at the periodic table as a whole. There's 2 different ways to look at the periodic table as a whole. The first way is what are called periods, and the periods are the horizontal lines that go across. Each one of those is 1 period. And you'll notice that I colored in the periods, but I skipped this part in the middle. The reason that I skipped this part in the middle is because these are called transition metals. These are kind of weird, and we're gonna basically ignore those because they can have different numbers of valence electrons, and they kind of mess up how the periodic table is arranged to an extent. So periods are set up so that the atomic number, the atomic mass, and the number of valence electrons increases as you go from left to right. So, like I said, the exception to that is transition metals, because they can have different numbers of valence electrons. The last way that we can look at the periodic table is what are called groups or families. And groups and families are the vertical columns on the periodic table. And groups and families are going to be more important than periods, because every element in a specific group or family has the same number of valence electrons. And because of that, they have the same characteristics, the same properties, they react the same way to different atoms. So the groups or families all have the same number of valence electrons, and they're the vertical columns. So this is how you read the periodic table. We're going to use this the whole time we're doing chemistry, so make sure that you understand it.